Today we're going to continue off from where we ended yesterday, where we defined the sine and cosine functions. And just like we did with tangent, once we learned what they were, then we could apply them to solving for the sides of a triangle. Before we get into it, these are our bell ringers. Usually I don't show the bell ringers just because of time's sake. I'm going to show them here just to review and remind a little bit. The abbreviation for sine, cosine, and tangent: sine looks like sin, cosine is just cos, and tangent is just tan, so those are easy. You can only take a trigonometric function of an angle. Okay, you don't just put tan with no angle there, because tangent just refers to the ratio opposite over adjacent. You have to say tangent of an angle so you know the specific sides that you're dealing with. The three words that help us remember sine, cosine, and tangent, that is so, ka, toa. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Write the sine, cosine, and tangent functions with the letters for angle J. So they told us angle J, so we want to do sine of J, cosine of J, and tangent. So give ourselves a little more space there, tangent of J. Well, sine of J, sine is so it's opposite KL over hypotenuse KJ. So KL over KJ. KL over KJ. The cosine of angle J is adjacent. It's our ka, adjacent over hypotenuse. So JL over JK. And then finally, tangent J, toa, so tangent is opposite over adjacent, so KL over JL. And there we go, sine, cosine, and tangent of angle J. Now, here's the setup for solving these right triangles that we're going to be working with today. And we are going to do the same thing we did where it's set up, substitute, and solve. But setup you have to just be a little bit more careful with. When you set it up, you first want to identify one of the angles you know, one of the acute angles that you know. So find one of those first. Okay, label from that angle you know the opposite and adjacent and hypotenuse. Okay, just put an O, A, and H for them. Then you're going to choose your sine, cosine, or tangent function. Now, when you choose which one you're going to use, it's your choice. And there's not always one right choice. Sometimes we have multiple options. But when you do this, you just want to make sure, as you kind of think through, do I want sine? And you think about opposite and look at the hypotenuse. When you choose that ratio, you want to make sure you only end up with one unknown in it. So if you chose the sine function and you didn't know opposite and you didn't know hypotenuse, it really wouldn't do you any good. You have to know one of the variables, or at least one of the sides that you are using the trig function for. So our setup, you can see, just a little more complicated there. Then we substitute with the same substitution methods we've used all the time. Then we're going to do multiply, cross multiply specifically, and use a little algebra to solve these. So let's get right to an example. So you're given a triangle here. You want to idea a couple of things. First of all, we know it's a right triangle. We've got our hypotenuse right over here. Here's the angle they told us, the 26. So as we start to think about how we're going to solve it, now let's first focus on x. And we want to think about x and how it is relative to 26. It's the opposite side. That means we want to use a trig function with opposite in it because we're solving for that. So I'm going to write these trig functions down. and this is our SOHCAHTOA here. And so as I'm picking my trig function, I'm looking for the opposite side. So I have to have opposite in the trig function I use. That means I'm either using the sine function or the tangent function. And then what side do I know? And that's the hypotenuse. Okay, so this is opposite and hypotenuse right here. So let's go ahead and label these things first of all. Let's put an O here, hypotenuse there, and an A there to identify them. So I'm looking for O, but I know hypotenuse. I'm certainly going to try to use the sine function here. So our setup would look like this. The sine of, now let's give this, and I'm going to call it something differently. I'm going to use E, F, G. So sine E here would be equal to the opposite side, F, G, over hypotenuse, which is EF. Now, instead of doing our setup like this, I think it's going to be better for us to actually work it this way. I think I'd write sine of 26 equals opposite over hypotenuse. So sine 26 equals x over 14. Now I'm going to put that over a 1 so that I can cross multiply when I solve it, giving me 1x equals 14 sine 26. And then you'll get out your calculator and we will find the decimal value for it. Before we do that, though, because I like to group these things, let's go ahead and do the y value here. So as we look to try and solve for y is the adjacent side here. And we know the hypotenuse for certain is 14, so we're looking for adjacent, but we know hypotenuse, that's the cosine function. So we'll go the cosine of 26 is equal to adjacent over hypotenuse. So the cosine of 26 is my adjacent side, which is which is y, over hypotenuse, which is 14. We put it over a 1 and we cross multiply. Y is equal to 14 times the cosine of 26. I'm going to grab my calculator here and I'll find the sine of 26 and I'll take it times 14. I'm getting x is equal to about 6.14, and then getting out my calculator again and finding the cosine of 26 and taking that times 14. And I'm getting y is equal to about 12.58. So there's our x and there's our y values. Let's go through another one of these things. Find A and find B in this function, or in this triangle. So again, start with or identify first the angle you have, okay? Now we're first solving for A, so let's figure out what A is. A is our hypotenuse in the triangle. So let's go ahead and label these things. Hypotenuse, this is our opposite side, and that is our adjacent side. Let's write down our SOHCAHTOA, so you have that right next to you each time you're trying to solve one of these problems. I'm trying to find the hypotenuse first, so I certainly want to use either sine or cosine because they have hypotenuse in their ratio. And I know the adjacent side, so I certainly at that point I'm going to make the decision to use the adjacent and the hypotenuse one. I know A, but I don't know H. So our setup looks like this. The cosine of 48 would be equal to the adjacent side, which is 10. Oops, it's not substituting yet. Adjacent over hypotenuse. So cosine 48 equals 10 over A, because that's the symbol they're using for it. We'll put it over 1. This time when I cross multiply, I'll do the A times cos 48 first. That gets my A on the left-hand side immediately. And 1 times 10, and then we just divide away the cos of 48. So A equals 10 over cos 48. We get our calculator and figure that out. Let's go ahead and find this opposite side over here now. Opposite, and I know adjacent. So I don't know opposite, I do know adjacent. That's opposite adjacent. I want to use the tangent function for this one. So I'll go tangent of the 48 is opposite over adjacent. So tan 48 is opposite is labeled B and adjacent is 10. And we cross multiply. So B equals 10 times the tangent of 48. Once again, I'm going to go to my calculator here. And I'm going to take 10 and I'll divide it by 48. Cosine equals, I'm getting about 14.94. And then up here, tangent 48 and times 10. I'm getting about 11.11 for that side. And we're done. Another example for you. And so think to yourself as you're looking at this, I got a right triangle, which angle do I know? I know this one. So go ahead and label your sides now. This is my opposite side is over here. My adjacent side is right next to the 65, and my hypotenuse is right there. Then go ahead and write down your sine. Oops, let's just write SOHCAHTOA. So you have those to reference. And let's see what we know and what we're trying to find out. In this case, let's see here, they're looking for u first. So u is the adjacent side. So that means I'm going to have to either use a cosine or tangent. And they give me the hypotenuse. So if I'm looking for adjacent and I know hypotenuse, that means I'm going to use the cosine function. So the cosine of 65 is equal to adjacent over hypotenuse. So cosine 65 is our adjacent side, that is u, over our hypotenuse, which is 8. And we cross multiply. I'll take 1 times u and 8 times cos 64. Let's find side t. T is opposite, and I know hypotenuse. So opposite and hypotenuse, I want sine function. So I'll go sine of 65 equals opposite over hypotenuse. So sine of 65 equals t over 8. Put it over 1. 1 times t is t, and then 8 sine, or 8 times the sine of 65. And I'm not quite sure why I put a 65 or a 64 on the left-hand side here. So let's go ahead and change those out to what they should be. 65, 65. There we go. So let's go ahead and find cosine 65 and take it times 8. So 65 cosine, that's about 0.42 times 8. Getting about 3.38, we'll call it. And then 65, and we will take the sine of it and take that times 8. And that gives me about 7.25. And we are done. Another one. Hopefully you guys are starting to understand the pattern here. Let's write down SOHCAHTOA. SOHCAHTOA. We got the 20 degrees. Let's see, they want S first. S is the opposite side, so that's either sine or tangent, and they give us adjacent. So opposite and adjacent, we're going to be dealing with tangent here. Let's label these things. Opposite, adjacent, hypotenuse. And so if we're looking for opposite, but we have adjacent, we use the tangent. So tangent of 20 is going to be opposite over adjacent. So tangent 20 is s over 117. S, not always a great variable, as you can see, kind of looks like a 5. So we'll put the tangent over 1 and we will cross multiply, giving us s equals 117 times whatever the tangent of 20 is. Calculator will know that one for us. See, find the t here, that's a hypotenuse. And we know the adjacent side. So adjacent and hypotenuse are involved. That's our cosine function. So cosine of 20 degrees is adjacent over hypotenuse. So cosine 20 equals 117 over t. And we'll cross multiply. I'm going to do the t. Cos 20 equals 117 and divide by the cosine of 20. And again, we grab our calculator and we'll figure out the decimal approximations for these. So 20 tangent, and we'll take that times 117. It's about 42.58. And then we'll do 117 divided by 20 tangent. I'm getting that t equals 321.45. That's it. The rest is your homework assignment. I actually took off number 4, so when you pull this up in the classroom, you'll see number 4 is not present. So just 3 of them.